Going to that topic, let me give a short summary of today's total contents. Today, first of all, we have to go through the basic structure of the distribution systems, because we are all going to do the network reconfiguration for a distribution network. If you have the complete knowledge about the distribution structure, then only uh, we can go ahead for the different kind of configurations by means of some kind of sectionalizing switching as well as the tie switchings. Then after that we'll go for the topic that is called requirement of the distribution feeder management. What is the basic necessity of the distribution feeder management? So in earlier time, our network was very simple. Distribution network means it is the intermediate network between transmission side and the utilities. And previously what happened, there was no connectivity of any kind of sources there. That means the distribution network was previously completely passive network. But nowadays, due to integration of renewable sources as well as energy types, energy storage devices and other things, it is becoming more complex network. And it is not nowadays not at all a passive network. It is it is rather than active networks. So while this network is changing by introducing such kind of renewable sources, like a PV source as well as some kind of that wind energy sources, then what happened, definitely there will be some issues for stability, voltage related issues also there, some harmonics related issues also will be there in the systems. So that is why we need to have some management, feeder management. That problem can be shot out with the help of feeder management. Now after that, we need a system of improved power system where the losses will be less and voltage profile of all the distribution node almost near to the rated values of the devices. That is also more important part. So that is why from a distribution side, we need a complete network where we can get such kind of such types of facility. With the help of some kind of network restructure option, where the monetary involvement is less. This can be solved by utilizing of different kind of tap changing transformer as well as some kind of FAC devices, but it will involve lot of monies. That is why we are going for that kind of network reconfiguration technique. Now after that, we'll go through the voltage stability issues in general in the power network. Then how that voltage stability issues can be solved with the help of the conventional approaches like using tap changer as well as the SBC and FAC devices. How it can be solved, that part will be covered. Then finally we'll go for the methodology that is called reconfiguration and its application for why it is utilizing. Then how we can do that reconfiguration with the help of manually how we can do that part I will describe. And finally I'll go for graph theory application for this reconfiguration technique. Now just you see, In power systems, the basics elements are what? We are having some generating unit where power is generating. Then after that we need some electrical network through which power is delivering from generating side to the utility place. That network, as per the voltage level, when the voltage level is high, then it is called the transmission network. When the voltage level is less, then it is called the distribution network. Now you know, while the power is generating, that power is transmitted through a transmission line by means of high voltage line. Why it is so? As you know, the power is equal to what is that? Vi into cos phi. For a three phase, root 3 VL IL into cos phi. Now you see, for a particular fixed amount of power, if we increase the voltage level, then what happen? Your current level will be less. So then that is why during transmission we are sending the power at high voltage level such that the current carrying in part that current which is flowing through the line will be less amount. That as a result, what happened? As a result, the volume of the conductor which is required for the transmission line will be less, as well as the, for a long transmission line, the I square R loss also will be less. That is why we are sending the power for transmission as at high voltage level. And after that transmitting the power, it will, then after that there are that electrical network is called the distribution network. In the distribution network, normally its level normally 33 kV to there. In distribution side there are two types of distribution. One is called primary distribution, another is
Yes,
called
Bhushan.
secondary distribution. In the
Yes.
primary distribution side, what is happening? In the primary distribution side, yeah, the voltage level is normally 33 kV to 4 kV level, and uh, in secondary distribution it is lower than that one. That means 440 volt, as well as is for three phase, and 230 volt for single phase. Now you see, this is a typical electrical network where it's showing that power is generating from a generating station, and from that it is delivering to a consumer premises. Now this is a very small network only. Nowadays, you know, one can also generate it as a captive power stations. In that captive power station means they are having some generating station nearby load center only. There is no there is no transmission, no transmission part is there, because they are directly getting the power. So here you see the power is generating somewhere, some substation is there. After that the substation is a operating the is here for controlling the power and monitoring the power and protection purpose only. Here substation is there, and after that that power is delivering to the, you see, to the a consumer places, right? So this is a typical type of network from generation side to consumer premises. Now as I told you, you see that this is a primary distribution network where the substation is giving 33 kV or 11 kV level, and from that only initial level we may have big type of consumer as well as the small consumer also. So that big type of consumer, they are getting three phase power directly like factory, and this is the at high voltage level, mean at 11 kV and 33 kV level, right? Now, and this is about the secondary distribution side. You see the power is coming from 11 kV side, from it may be delta star connected, and for the primary side is delta and secondary side is star, such that why star? Because in star side we can get one neutral line also. So it is one neutral line we are getting, and from that only we are giving the power to different household, right? So we can give the power three phase power for big factory. We can give the single phase power also 230 volt. So this is the basic layout of a secondary distribution system.
Sir, good morning, sir.
Now, the
Sir,
normally
మీకు ఏం
the
వస్తుంది సార్
distribution
మీకు?
network is radial type. Radial means there is
అర్థం
no
కావట్లేదు
mesh.
సార్ మ్యాక్సిమం.
So
ఒక్క నిమిషం.
they are getting the power from the
మీరు
substation,
జాయిన్
and
అయితే
from
ఏమవుతుంది
that
సార్?
one
నాట్
feeder
జాయిన్
is
అయితే
there, and from that feeder some distributor line is there. From
మీకు
that only
మ్యాక్సిమం
they are
జాయిన్
getting
అవుతున్నారు సార్ మీరు.
loads are
అబౌవ్
getting the
కొడితే సార్
power. So this is one
ఏ మెయిల్
type
ఐడి
of
సార్ మీది?
this is one type of
ఓకే.
network
యాడ్ చేయడానికి వస్తుంది.
configuration.
ఒక్క నిమిషం
So
సార్.
another type of
ఒక్క
also
నిమిషం నాకు
network
మెయిల్ ఐడి
configuration is
పంపించండి.
there. You see some substation is there, and from
రైట్ సార్.
that one feeder line is there. After that some transformer which is converting 11 kV to 440 volt, 4, 4, 400 volt, or as well as the single 400 volt three phase, and for single phase 230 volt. From that load are getting power, right? So here also you see at the left side we are getting the power from high voltage side or millivolt substations. Then from that on, from that, through some distributor is there, and for protection purpose we are utilizing some kind of fuse here. After transformer some fuse are there, so through fuse only the consumer are getting the power. So these are the different types of the. So you see now here some low voltage feeder, through that also you see different types of power getting by the consumer, like that. So sometime in distribution side, sometime the power is distributed through overhead line, and sometimes the power is given by cable. In densely populated area normally power is given by underground distribution.
సార్, గుడ్ మార్నింగ్ సార్.
So for that they are utilizing
చెప్పండి.
cable only. And normally in our urban area where the
చెప్పండి.
population is not so much,
మీటింగ్లో ఉన్నాయి తర్వాత.
for that what happens, power is given from substation via some overhead line, that is via some overhead line. So this is a typical structure of a distribution network. From substation different feeders are there, and from the different feeders through service mains only power is delivery. Okay.
ఏంటి కొంతమంది
unable to join and capacity ఎంతది?
So this is another type of structure. You see that
గూగుల్ మీటింగ్
from here you see one substation is there, and from that three different distributors are there. Through that only power is giving, right? Power is giving through that only. Here one thing you can see, here we are having some mesh, right? And another one to see in this, in the right side you can see we are giving the power through some feeder to that particular to some consumer premises. Now you see in this case, in the first case we are having how many from substation to a particular distributor we are reaching by how many ways. By, you see, one way, one path is there from this, as well as another path is there. By different paths is there, and for the right side you see the power is delivering from one side to another side by two feeder. Here one people may consider, may think, why we are utilizing two different feeder. Actually sometimes what happen, if we have only one single feeder, then what happen, if some fault is occurred in the single feeder, then the consumer will not able to get the power. Now if we have the two number of feeder, then what happen, if at any situation or any instant one feeder having any issue, then through another feeder we can we can send the power to the consumer premises. In that case what happen, your reliability of the system is increasing. But whereas if you see the this network, this radial network, in that case what happen, you see, if any fault is occurred in any of the feeder location, then what happen, then loads may not get the power at that instant. Okay, so that is why if we have such kind of configuration of the system, then what happen, then our reliability will be increased, reliability of the system will be increased. So that is why so this is the drawbacks of the radial network. But radial network also have some kind of advantages. So I'll discuss these things in my next after some times, which is very much important
దాంట్లో
part
రెండు
for our
అంటే ఏంటి
configuration
బ్రదర్
techniques.
రెండింటికి ప్యారలల్ పెట్టాము.
So now the question is that why we are going for distribution feeder management. So in distribution system, what happened? Nowadays we are introducing different type of distributed energy resources, like different type of renewable energy sources, as well as diesel generator, as well as different type of fuel things, fuel, energy fuels. And while we are putting that one, what happened, the sometimes due to the intermittent nature of the renewable resources, sometimes power injection to the network maybe suddenly rise, and sometimes suddenly it is decreasing. What happened now, for a power system, if there is some mismatching of the power in between generation and load, some stability issues will be there. If whatever the active power generation, if the same amount of the reactive power generation is there, reactive power utilization is there, then there is no mismatching, then there is no stability issue. Now if some mismatching is there between source and utilization of the active power, then some issues will be there, that will lead to the system frequency issue, that frequency stability issue will be coming. As well as if some mismatching of the reactive power will be there in between generation and load, then some voltage stability issues will be there. So this is one kind of issues which are facing of the distribution network due to the introducing of the renewable sources in the system. As well as while the renewable energy is utilizing in the sources, we need different kind of converter in the system,
అదే
um,
దానిలో మనం
like
వాడుతున్నాం కదా సిస్టమ్
we need inverter as well as the rectifier. So now while you are using these kind of things in the network,
ఆ
that
ఎగ్జాంపుల్
time
చెప్తా
that will inject
చేసే
some
దాంట్లో
kind of harmonics in the system. So
ఓకే
that
బ్రదర్
will
ఓకే
also make some kind of problems to the grids, right? So so this is one kind of issues. Another kind of issues nowadays, we are utilizing different type of
భయ్యా
vehicle,
సారీ
electric
నెక్స్ట్
vehicle,
చూస్తా కొంచెం
and for charging purpose. So now if as our demand day by day is
హలో
increasing, then what happen, it may give
హలో
a overloading impact to the transformer as well as
హలో
the
సార్
feeder also. As a result, what happen, feeder will be
సార్
congested
ఏం
and
లేదు
it will
ఇప్పుడు
be
ఈ
overloaded also. So
నెట్వర్క్
due
లింక్
to
ఏంటి సార్
these
ఇది
two
నెట్వర్క్ లింక్
reason, we need to have some kind of
ఇది మన
feeder management.
ఇదే ట్రిపుల్ హెచ్ఓడి దాంతోనే
So now we are going to resolve that issue
మామూలు మనకు ఛార్జెస్ ఉంది యాక్చువల్లీ
by obtaining some kind of
ఆ
improved
ఛార్జెస్
power
మీరు
system
లింక్
operations.
ఎలా
Now what it means, what do you mean by
లైవ్ రికార్డింగ్
improved
ఉంది ఆప్షన్
power system operation? That means uh, we have to get, that means we have to get that
యూట్యూబ్లో లైవ్ పెట్టమంటారు అంతేనా
higher voltage
స్ట్రీమ్
stability. What the stability
అంటే
meaning?
ఈ లింక్
I'll
మరి అది
explain it in
షేర్
my
చేస్తే
next slide. Next,
షేర్
the thing is that we should have
మొబైల్
ఓకే ఓకే ఓకే
a
షేర్
very
చేయండి
less amount of
Okay, sir.
loss, active power loss, as well as we should have a radial network, because radial network having there some own merits. So if we operate a system in radially, as well as if we get the less amount of active power loss as well as reactive power loss for a particular network, as well as if we get a stable voltage for a
నాకు ఇంత
particular
ఇంత
systems
అయిపోయింది.
for each of the nodes, then it is called a improved power system network. Now,
Go to the
the definition of the voltage stability. So, voltage stability is a concern with maintaining the acceptable voltage all at all the system buses under normal condition, as well as when the system is being subjected to the disturbance. So normally in transmission network there is a less number of
లేదు.
buses, but while we are going for distribution network there will be
లేదు సార్.
more number of buses, and the system is weakly mesh condition. That means there is lesser number of loops, and we are going to operate it in radially, and the r by x level is very poor. That means in case of transmission level the r by x level is
ఇది కాదు.
high, whereas sorry, x by r level is high, whereas in case of distribution level the x by r level is very poor. So now the thing is that we in distribution side we have to maintain a voltage, a operating voltage level, a fixed operating voltage level. Normally, see 0.8 per unit. That means what? That means if we have say 100 volt, suppose if the operating voltage is say 100 volt, now we should not tolerate less than 80 volt, or maybe another for lower level, and for upper level 120 volt. So if it is below that 80 volt or more than that 120 volt, then the system become you know unstable. So the voltage collapse phenomena in a now these voltage stability normally in transmission system we are thinking about the voltage stability, whereas in distribution side we are considering only about the voltage level. But still in distribution side also we are having researcher has developed some stability indicator through which they can assess the system stability, that overall voltage stability. With the help of that one they can check while a system is running
మీరు ఇప్పుడు
at
దీన్ని
different
టైం
loading condition, whether system is in stable condition or in unstable condition. Now, as I already told earlier, the voltage stability phenomena normally occur due to the mismatch of the reactive
దాని
power
గురించి ఒకసారి
uh, only. That means what about our reactive power generation? If our load is consuming more than that one, or if it is consuming less than that one, then the voltage stability issues will be there. If a load is consuming more than its generation and of the generation of the reactive power, then what happen? Then our voltage will be drooping. And if sometimes our generation of the reactive power is more, but if we are utilizing the less, then what happen? Then our voltage level become
ఒక 2 నిమిషాలు.
more. Like during a lightly loaded condition, due to the Ferranti effect, what happened? You can see our generation of the reactive power is more, but our utilization is less. Due to that reason, what happened? During lightly loaded condition, what happened? Our voltage profile will be more at the load side. So this is because of the charging line charging capacitor. They are giving some giving some kind of reactive power injections, leading bar injection. Due to that one only these problems are happening. Okay, so now I'm showing a curve through which we can explain the voltage stability phenomena. Now here, you see, we are having two axes. The y-axis represent the voltage level in volt, and the x-axis represent the power transfer. Now, suppose we are sending a power from a generating station to some load part. Now you see, if we are changing the power, if we are increasing the power, you see our voltage is, you see our voltage is, lowering, means our voltage is
ఎంత
decreasing.
పడుతుంది అది హైట్
See,
కిందకి
see, we can tolerate that voltage up to some
ఏంటిది
level.
మనకి
After that, you see that
గూగుల్ టిక్ టాక్
voltage
సౌండ్ ఆన్ చేయొచ్చు
are coming under unstable condition. So if you are increasing our load, our system may run to a stable condition till some point. After that, some margin will be there. So this is the alarming zone. So we have to check, we have to resolve our issues if some issues are there during that condition, during that marginal condition only. Otherwise, if the problem will go till that need point, then after that the system become collapse. So after that the system become unstable. So here, this curve is referred as PV curve. So if we, for a particular bus, if we are just increasing the load, what happen? Our operating voltage level or operating point of the voltage will be decreasing, and after certain point we'll get some marginal value. Means we have to take some corrective actions by means of injecting some kind of var,
అది
or we have to take some other arrangement. Otherwise the system become
లేదు
unstable.
ఒక
Means
2 నిమిషాలు
after that
కాల్ చేస్తా
some failure will be there in the grid, that will lead to cascading failure in a system.
ఇది
So here, see,
ఏంటంటే
I am explaining. See, if you are just changing the load,
మనం ఏం
how
చేయాలి ఇప్పుడు
you see how the operating point is shifting.
కాదు
You
ఇంక్రీజ్
see,
చేయాలంటే
the
మనం
number
కరెంట్ ఎంత
of bulb
పెడితే
is
వస్తుంది అది
increasing, the
దగ్గర
operating point is shifting, and now
ఇంకేం
still it is
చేస్తున్నావు
shifting. If still it is operating,
నేను ఫోన్
now you
చేస్తా
see after that knee point, some kind of phenomena is
ఫోన్
occurring.
చేస్తా
See,
కాల్ చేస్తా
yeah. See, after that, see some voltage collapse phenomena is occurring. So I hope that it is clear to all of you till that point. So is it clear? Okay. So next I am going to the next slide.
ఒక్క నిమిషం
So now, uh, in the last decade, uh, a number of incidents was happening due to the voltage collapse phenomena. So these are some of the things which was some of the reported things uh, which was occurred across the globe, and million of the people was suffered due to that blackout. Okay, so these are some date wise reporting.
అంటే తెలుస్తాయిలే మనకి ఇట్లాంటివన్నీ సార్ ఇప్పుడు మన గూగుల్ మీట్లో మ్యాక్సిమం ఉంటాడే కదా
Now I am going to
పార్టిసిపెంట్స్ చేసేది
discuss about the principal reason of the voltage instability. So the basic
అవును దాన్ని
reason
చెక్
behind the
చేసుకోవాలంటే
voltage
ఎట్లది
instability is that the excess load. This is overall view of the power system. This is
మరి అదే
not
అది ఎట్లా
only
పడుతుంది
valid for distribution network, even for even for transmission network also these things is valid. So now if we are having the excess load in the transmission or as well as the distribution side, then we are having some voltage
ఓకే ఓకే
instability issue. Then if we have a large distance between the generating source and load also, then the voltage level
అదే ఒక
issues will
ఒక
also be there.
అదేలే కొంచెం
And
ఇంక్రీజ్ చేసుకోవచ్చు
sometimes due to
ఫ్రీక్వెన్సీ
the lack of the reactive power compensation, the
ఎక్కడ అది
voltage stability phenomena is occurring. So
ఓకే
how this
మామూలుగా
problem can be resolved? This problem
సరే
can be resolved
కొంచెం
with
ఇంక్రీజ్
the help
చేస్తున్నాను
of some devices
అదే
like
అదేలేండి
we can utilize
కొంచెం
some kind
చెప్పండి
of
చెప్పండి
reactive power
అంటే
support
లైన్లో ఉన్నాం అందుకని
using capacitor.
ఉమ్.
So if you use some capacitor, they can inject leading bar to the system.
అవునవును కొంచెం చూడండి సార్
Then what happen?
చూసిన
Then
మళ్ళీ
if the
ఒక
system
హాఫ్
are
అన్ అవర్ 1 అవర్
facing
లోపు చెప్పండి
some voltage level issues, suppose due to the
లింక్
overloading, if
ఎక్కడ
voltage is
పర్చేజ్ చేయాలనేది
going down,
తెలియట్లేదు
then we can introduce some
అంటే
kind of
యాక్చువల్గా మాకు
capacitor bar to the
2000
system
ఎక్స్ట్రా
which
పెట్టుకున్నాం
can
అనమాట
increase the voltage
2000
level.
లోపల ఉంటే తీసుకుందామని
As well
చెప్పేసి
as
ఒక 1 వీక్
if we utilize some fact device, that
1 వీక్
also
అదే
fact
అదేలేండి
device means some kind of power electronic devices which can control the
రీస్టార్ట్
reactive
ట్రైనింగ్
bar
అంట 14 డేస్ అంట ఇది
by means of switching. Okay, so that is called the fact device. Okay, so as well as we can utilize some tap changing transformer. And another way is there. Now if we have say more number of load, we can reduce some of the load, means we can shed some of the load from the system. That is called the load shedding. So now I think this is not feasible things, but still people are practicing such kind of things. Whenever you may see, you may have some experience during summer time when the number of load will be more frequent, you are getting power cut problem. Okay, power cut of issue, you can face that problem. So whenever the load is more, they are just zone wise they are shading the loads. So that is also one of the solutions. But this is also not this is not effective solution. But to reduce the burden on the grid, and to avoid the blackout situation, still people are utilizing that techniques. But apart from this, you see, we can utilize the capacitor for improving the voltage level. We can utilize fact device, we can utilize the tap changing transformer also. But these are all involved with monetary problems. It means monetary, so lot of money is involved in with such device to control such issues. Okay, so that is why we need some kind of alternative solution, which can give the same result, but but the monetary involvement for such case will be less compared to the that other solutions, right? So that is why we are going for network reconfiguration technique. So network now, the needs for the network reconfiguration, we are experiencing that for managing such issues, if we utilize that technique, we can solve the same problems. Okay, so is it clear till that point? Is it clear to everybody? Hello, till that slide, is it clear to everybody? So now
Yes, sir.
here
Carry on.
now here one I'm showing. Hello, yeah, now here I'm showing you some picture of the on-load tap changers. As I told you, the on-load tap changer can be utilized uh,
150
in a distribution side, uh, uh, see, whenever your voltage level is less, that we can change the tap position, uh, maybe primary sides or maybe secondary side. Normally it is doing in high voltage side. Okay, if we make the change, if the tap is connected in high voltage side, what is happening? The high voltage side voltage is more, but current level is less. When you are changing the tap position, so some sparking or will be there, or some arcing will be there, and that sparking or arcing is normally normally coming due to the current only. So wherever the less current, there will be less sparking. So that is why normally we are doing the tap changing in high voltage side, not in low voltage side. So now for voltage control also we can utilize some voltage regulator. You see, this is another type of regulator which can be utilized
Actually,
in
SUIT, huh?
inline transformer. So now, as I told you, that the capacitors, so capacitor can also be utilized for improving the voltage level, because they can inject the leading bar to the system. So some series capacitor is there. So this is the figure of the series capacitor, and we can place in a particular nearby substations also. And this is some type of the capacitor. We can introduce that things also. So these capacitors normally injecting the leading bar uh, when it is required. Means, suppose for a particular system, if they are introducing too much of load, then voltage profile will be less. That
Daddy,
time we can inject the leading bar to the system by means of such kind of capacitor. But sometimes when our load is less but our generation is more, then what happen? Then some problems will also be there. Means, sometimes our when our load is less but our generation is fixed only, then what happen? Then our voltage profile also may increase. So to reduce to eliminate such impact, we can sometimes we can introduce some type of reactance also, that will inject the lagging bar to the systems. So this is a picture of the shunt type of reactance. Now this is about the FAT device, flexible AC transmission system. So now here what is there? So, we can have the option, particularly in SBC, static bar compensator. We can have options of injecting leading bar. Top, you see, we can
You done and put and start streaming low
means of
notification.
the firing angle, by means of the firing angle of the by means of the fire. Hello, my voice is audible.
అది లిమిట్ కదా ఇంకా.
So by means of the firing angle of the that power electronic devices. So now whenever our load is less, that time, since the voltage level of the of the bus is more, that time we have to inject the lagging bar with the help of such a power electronic device. But whenever we need to inject the leading bar, that time we can utilize the switches which is connected in series with the capacitor. So in that SBC we are having the provision for injecting leading bar as well as lagging bar, as well as lagging bar. So whenever our voltage level is more, that time we are injecting the lagging bar. Whenever our voltage level is less, that time we are injecting the leading bar. So based on our requirement, we can have some control arrangement, we can do it. automatically. So this
QISCET
is
pricing
the
scale
working
amateurs.
principle of the SBC. Similarly,
ఉన్నారు ఎవరు
whenever the power is
ఎస్ఎల్ కాల్
flowing
చేసి
from one line, one point to another point, that power which is flowing from one point to another point can be expressed mathematically, which is given by
NIT వాళ్ళకి కూడా మ్యాక్సిమం
E
ట్వంటీ సో
V
మెట్టుపల్లి
sine
పెట్టమన్నారు
delta
ప్రీవియస్ అడుగుతున్నారు.
divided by X. So that X is the reactance of the transmission line. Now
మీరు పర్సనల్గా కూడా
now
అక్కడ చూపించారు
the
అది
for a particular
QISCET.
transmission line, the loadability means how much power for a transmission line as well as a distribution line also, how much power they can flow
గూగుల్లో కొట్టు
from
గూగుల్లో
one side to another side, that can depend
సెర్చ్ జీ సెర్చ్
on
సెర్చ్
the value of X. So now
మార్చింది కదా
the
దాన్ని గో
the
షూట్
TCSC is
గో షూట్
one device that is called thyristor control series capacitor. They can change the value of the X of the transmission line as well as the distribution line also, and they can change the value of the power transfer capability of a transmission line. So sometime we may have some kind of congestion level of a transmission line. So if you utilize such kind of things, that power transfer capability can also
కొట్టే
be
ఆల్రెడీ
increased.
దీంట్లో
That means the loading
రావట్లేదు
capability for a transmission line as
ఇది
well as the
రావట్లేదు
distribution line can also be increased with the help of this TCSC, that is called thyristor control switch
రావట్లేదు చూసాను
capacitor.
పైకి చూడండి నెక్స్ట్
So
మీ ఈమెయిల్ ఐడి
some other apparatus which can be used in distribution system, that is called the fuse. So whenever some fault is
ఇది
there,
ఆర్డిటి మనం
the
పెట్టింది
fuse is operating. So this is, you see, one fuse.
ఇది
Okay, and sometimes in distribution side we are utilizing also the recloser.
డొమైన్
Now
అడుగుతాను
what is
డొమైన్ కనుక్కో
recloser? Recloser means if in a
ముందు డొమైన్
system, if
ఉండాలి
in a distribution system, if
అంటే
there is
ఏదైనా
any
డొమైన్
fault,
ఉండాలి
then whatever recloser will act
ప్రకాష్
immediately,
అడిగితే ఇట్లా
and it can remove the system from the generation side, and after some time it will once again close, and it will check whether the system having any fault or not. If it is or it will check whether the system operator already cleared the fault or not. If it
ప్రకాష్
has been cleared,
దేనికైనా
they
ముందు
can after
సిస్టమ్స్
some time
టైం
it
ప్రాబ్లమ్స్
will be
ఉంటాయి
closed
అలాగే
once again. Otherwise it
ఎస్బిసిలో
will open only. Okay, so this is about
కంపెనీ చూడండి
the recloser. Now in distribution side we are utilizing the
బట్
sectionizing switch
యూటీ
also.
రావట్లేదు ఒకసారి డొమైన్
Normally
కొడుతుంది
the with the help of that one, we can it will act as a switch only. Sometimes we can utilizing the switch in a feeder. This can be connected in
బట్
series of the
వచ్చేది
feeder
ఎలాగో
line. So suppose if you want to
ఇది
remove a
అన్లిమిటెడ్
feeder
అది
from the main source, so we just open it. The
ఆర్ వి కెన్
sectionizing switch
ఇంక్రీజ్
is
ఇట్
normally
ఎనీ
closed,
అదర్
and
ఫెసిలిటీ
whenever it is required
pay it
it will
to
open
total
only
remaining
as
2
per our requirement. So these sectionizer switch normally we are utilizing during our reconfiguration process. So I think uh, till that one, this is the introductory part of the of my network reconfiguration part, which is the prerequisite for the network
సో
reconfiguration techniques.
అదేలే
So till
ఎనీథింగ్
that one, if you
అప్రాక్సిమేట్లీ
have any kind of query or question, you may ask. So the next part I will start after getting feedback from your side only. So I am now requesting to all of you, if you have any query, any questions related to the topic, please ask me.
ఇది పార్టిసిపెంట్స్ 100కే వస్తుంది సార్.
Any query,
సార్
any
ఎవరి దగ్గర
questions from your side?
ఎంత 1260 ఎంత ఉందో అంతే కదా. మనం ఏదో బడ్జెట్ తీసుకున్నాం ఎక్స్ట్రా ఇప్పుడు 25,000
Any query? Hello, my voice is audible.
Yes, sir, it is very much audible.
So I need some questions from your
I
side. If you have, I think it should not be one side talk. Some interactive things also required, interactive part. So if you have any question from your side, please ask me, sir.
exactly, sir. In
From,
online mode, we generally suffer this type of problem from the student as well as from participant side.
no, from participants, I am requesting questions. If you have any query, please.
Sir, it would be great if you tell us something about the how do this firing angle is adjusted for the compensation of reactive power. If you could.
Sir, this is a completely different topic. If you give some means some small sessions for that one, I can explain it completely. Right.
Okay, okay,
This is
let
this
me
is
know.
about the working principle of the fact devices. Right. So, but I can give you briefly. That is that Uh, see, normally we should have some monitoring part which can give the details about the load profile from time to time. uh, and based on that information the signal will go to the controller to the fact device, and they will check every time whether that particular bus or node having the reference voltage, having the rated voltage or not. If it is less than that one, then how much sometimes the voltage of that particular bus more than that one, or sometimes it's less than that one. So based on that, if some times due to the inserting of the more load in a particular bus, if the voltage level is less, then suddenly there is a need to improve the voltage profile. So then they have to inject some capacitor. I mean, they have to inject some leading bar through some capacitor. In the SBC controller section, there is some control arrangement for particular var injection. For particular improvement, particular level of improvement of the voltage level, we need particular amount of var. And for that particular amount of var, how much, what would be the particular firing angle, that is already there, and they are having some lookup table also. Okay, so based on that only the firing angle can be adjusted, understanding. So this is for increasing. Similarly, this is for capacitor as well as for for reactive or injection also. Suppose if the voltage, lightly loaded condition is voltage is more, then what happens, they have to check how much voltage is increasing. Based on that, how much reactive var they need to inject, and based on that, what firing angle they have to choose. That lookup table also there. So from that only they are mm, utilizing that firing angle, and they are injecting that
Oh,
leading
okay, sir.
that var.
Okay, sir. Thank you, sir. Thank you.
Okay, but it is having lot of it is having lot of mathematical part. If you give some opportunity in future, I'll definitely explain complete design part. It is very important as well as very interesting also.
Okay, sir. Okay, sir.
So anybody have any questions? So from the participant,
కూర్చోండి.
anybody have any questions?
పర్లేదు చెయ్యి
ఆయనతో మాట్లాడుతూ ఉండండి.
So I have covered my first part. Now I am going to my second part.
ఓకే సార్ అంటా ఉండు.
So now network reconfiguration. So network reconfiguration means
ఇక్కడ
this changing of the network topology by means of some switching arrangement. Uh, In a distribution line, we are having the feeder line. Now, in the feeder, we can add series sectionizer switch, and sometimes we can add tie switch between two lines. So, if we change the status of the switch, this complete topological structure can be changed. And now you see, in a particular network, if we have say n number of bus, then we can have 2 to the power n minus 1 options. Means we can get 2 to the power n minus 1 number of topology. So now each of the topology having their unique feature, means each of the topology having their own load flow solutions, they are having own power loss, they are having different having own voltage profile. Now from one to another topology there is some distinguish by means of voltage level as well as the power loss. That means from one configuration to another configuration you can have some difference also. Different level of power loss,
సార్
different levels of voltage profile of each of the nodes.
మళ్ళీ వచ్చా
Everything is different. Some of the configuration
ఇందాక లాస్ట్ వీక్
so now
చేశాను
see, if we have
హలో
say 2 to the power hot if we have
ఆగండి
say
ఒక్క
a
నిమిషం
network which is having 10 lines, then we may have
సర్లే
2 to the power 10 minus 1 configuration. 2 to the power 10 means 1024 and minus 1 means 1023. So for a 10 line, for a 10 feeder system we can have 1023 possible number of topology. So out of this topology, huge number of topological structure, some of the topological structure will give us a, a very good voltage for a particular loading condition, very good voltage profile, very less amount of power loss, as well as active power loss as well as the reactive power loss. When your reactive power loss is less, definitely there will be voltage better voltage stability. Okay, so now our aim is to find that particular topology which is giving the optimal solution. So normally, the network reconfiguration can be done to relieve the overload in the power lines and to balance the network load and to optimize the voltage profile, to enhance the reliability, power loss minimization, load balancing, and sometimes for planning and marketing also we do, and another one is service restoration. So sometimes what happened, due to the a fault, some of the zone maybe uh, not getting the power for that instant. Now if we have the reconfiguration strategy with us, we can reduce the power for that particular zone uh, in different way. Suppose if we have some x zone having some fault, then we can reduce the fault, we can reduce the power for other zone by means of some reconfiguration techniques. So I'll explain that thing later on. So now I am explaining the network reconfiguration. You see, we are having some 8 bus network, right? And each, if, rather than bus, you can tell we are having 8 node network and 8 node network. So in case of distribution side, instead of bus, we can tell the bus as a node. So now, now you see between two bus, there is a feeder, and that feeder is in that feeder, in each of the feeder there is a switch. That switch is called sectionalizing switches. So these switches are sectionizer switches. Now by opening and closing, we can have different type of topology. So now, while we are making such different type of topology, we have to check which topology having the best voltage stability, which topology give the best voltage stability. That means for a fixed loading condition, if you make different topology, which topology will be good for good so far good for voltage stability. So now there are some different indicator through which we can assess the voltage stability. So in previous the previous researcher has developed some indicator through which stability can be assessed. The first one is voltage stability index using reduced single line equivalent network, then VCPI indicator, then VQ sensitivity indicator, then L indicator, PV by curve. PV curve I have already explained you, through which also we can assess the stability. Then bifurcation analysis and energy function analysis. Now, if one can want to do any kind of research on voltage stability issue, they can go through that indicator. And nowadays people are also working for assessment of the stability using this indicator. They are utilizing some soft computation technique, and they are publishing so many papers. So now I'll just go through only one technique, just the first one. Now you see how we can compute the voltage stability index for a single line equivalent network. In a power network, we may have n number of buses, as well as we may have n number of nodes, right? So now, if we want to analyze that each of the node, or if you want to assess that things, it is really complicated things. That is why the complex network can be considered uh, by one source as well as one load. That is here this here that approach has been utilized by a single line equivalent network. So here the complete that power that is given by that complete injected power, that is equivalent injected power, that is given by P, and complete reactive power given by Q. And V is the sending end voltage, R is the resistance of the line, and X is the reactance of the line, and QL is the reactive load, and PL is the active power loading. Now after analysis, it has been observed that P, that injected power, can be given by this term, that P equal to that one, as well as the Q can be given like that only. Okay, so like now after that one, after arranging that one, you see, now after that, so we are having P equal to like that and Q equal to like that, and from 1 and 2 we can have some kind of relation like that. So we can eliminate that one, that R squared, this one we can eliminate that part. So now after that we can have some kind of expression, so we can arrange that one. Now from that expression, we can have some expression like 4. Now you see, first of all, what we have considered here, we are considering complete network as a by a equivalent network. This network may have n number of nodes, that n number of node. Now we are considering that overall load of the node for active power is given by PL, and overall reactive power of the load is QL, and and that P is the injected real power, means and Q is the injected reactive power. So now equation 1 and 2 we can get it, right? And from that, now after rearranging that equation we can get equation number 3. Now the voltage at sending end we are taking as a reference voltage, and it is the magnitude which is kept as constant. Hence the sending end voltage we can assume that 1 per unit. Now if we put the sending end voltage 1 per unit, then we can have a quadratic expression of the P, and we can have a quadratic expression of that one, this one. So now, with the help of equation 1, 2 and 3, we can have one expression of the P which is a quadratic equation. Now, P is a real term. We can have a quadratic expression of the P, okay, and as well as after eliminating the P, we can get Q also. So if you utilize the equation number 3, we can, or if you utilize the equation number 1, we can able to eliminate P also, and from that we can easily obtain one equation of the Q. Now you see, from that expression we are getting two quadratic equation P and Q. Now this P value and Q value both are real value. Then if in a quadratic function both are real value, then their discriminant must be greater than 0. That means suppose if you have some ax square plus bx plus c equal to 0, then your x will be real for both condition if your b square minus 4ac is greater than 0. So now we are applying that one. Now if you are applying that one, then we are getting such kind of things, that expression we are getting. Okay, so equation number 8 we are getting. So now after that we are getting such kind of things. Okay, now we are putting one, that overall P equal, what is that? Loss as well as, hello, I think some noise is coming. Hello, 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 sir. Some noise is coming from background. Hello.
Yes, sir, I'm getting it.
Okay, okay, fine, fine. Now, you see, the total real and reactive power loss for a particular system can be computed like that. So, P equal to given by overall loss plus our, our load. Okay, similarly, Q can be given overall loss plus this. Now, after that, if you so now you see, our system becomes stable if you make such, if you find out that expression. Now in our stability assessment, if we check that 4 into xpl minus rql plus xql plus rpl is less or equal to 1, then only the system becomes stable. So now the question is, suppose we are having a system, how can I assess the system stability? So from the load flow itself, you have to check what is your overall x, what is your overall r, and that overall x and r you can obtain from this formula itself, right? From equation number 1 and 2 you can get it, and after getting that one, you have to calculate your PL and QL also, right? Right, PL and QL also you can obtain it. Okay, so now after getting that value x, r and PL and QL, you have to calculate the stability by computing that equation number 8. This will give you whether the system is stable or unstable for that particular loading condition. So this is one of the indicator. This is called single line to, this is called a single line equivalent network, which can which can assess this system voltage stability.
పెట్టి మళ్ళీ వచ్చి క్లాస్
Okay.
తీసుకోవాలా? ఇదో దరిద్రమా?
Now our objective is what in the present method we are going to improve the voltage stability, which comprising of multiple lines and switches, and it is suggested based on the reconfiguration approach without affecting the loads of the network. So you see, now in my presentation what I want to show you, I want to show that if we change the network configuration, then for a particular fixed loading condition, how stability can be changing. So now we may have n number of feasible combination of lines and switches, and out of that one maybe some of the configuration will be will be giving a better result. And while we are doing such kind of configuration, we have to keep in mind that our load should not be isolated
సెకండ్ యూనిట్
from the systems.
సబ్జెక్ట్ రాసేసి ఫస్ట్ యూనిట్
So we have been trying to get the combinations of switches and lines which result in highest voltage stability of the overall system, maintaining the loadability constant and power system network intact. Please take a look on loadability part. What is loadability? As I have already explained you, while the power is flowing from one node to another node, that particular line should have the capability limit to flow such amount of power. Sometimes if it is more than that overloading limit, that time what happens, the line will be congested and that line may not be tolerated that amount of power or that amount of current flow. So that is why while the power is flowing from one side to another side, we should keep in mind that our power flow should be under that limit, under that loadability limit, right, or capability limit. So here, as I explained you, a 8 bus network, we are changing the different configuration by means of the status of the switching, sectionizing switching by opening and closing that one. Uh, so this is some 8 bus network. You see their normal voltage is given in per unit as well as the angle, and loads are there. So we have we did some simulation using MATLAB, and this is the this is the bus data. Table 1 refers the bus data of the system, and table 4.1 and table 4.2 reflects the line data, or you can
You
think
are
about this is
coordinator for
some
FTP.
feeder data. So the feeder, that n bus, starting bus and n bus is there, and in between what is r value, x value, it is given, as well as b value also given. And in some cases you see the tap setting is normally 1, but wherever the generator, wherever the transformer is there, some tap setting value is there. You see it in line number 4. uh, in line number 4 there is a transformer, these two having two transformer, which is connected to bus number 1 and bus number 3. In between bus 1 and 3, you see in between bus 1 and 3 we are having one transformer, they are having some tap setting value. Similarly in between bus number 3 and 6 we are having some transformer. We can see uh, 3 and 6 some transformer is there, due to that one some tap setting value is there. Otherwise if the line is directed connected, there is no tap setting, means the ratio of the voltage of the two side is 1 only. So now this is a different configuration. So you see we are having how many switches, we are having for between two nodes, feeders are there. In each of the feeder we are assuming that one synchronizing switches are there. That switches has been referred by S1 to, you can see this switches is given S1 to S15, total 15 number of switches are there. And we are changing the status of the switching by opening and closing. So say 00 is referring the first
Voting
configuration.
electoral versus
So here
This
S15 is open and other switches are closed. Closed are indicating by 1 and opening is indicating by 0. So you see for this one we can have the stability indicator. So here we have calculate the stability by means of some L index, which can also give you the stability value for each of the bus. We are having total total 8 number of bus. Out of that 8 number of bus, bus number 1 and 2 having some kind of source. That's why we have not calculated their stability value. So bus number 1 and 2 having generator, that's why we have not calculated their stability value. But other bus having the loads, for this load we have calculated the stability value. If the value of the stability is nearby the 1, it indicating the system become unstable. If it is nearby to 0, means it is stable condition only. So here we are applying the stability, L index stability. So now you see these are giving for different configuration, we are getting different stability index. After that we are averaging all the stability index, and we'll get the status of the systems for that particular configuration for fixed loading condition. And if you see the configuration, for different configuration we are getting different type of stability index. And the stability index, you see, if you plot the stability index, you can see that L index value, average L index value is varying, right? In some of the cases stability index is more nearer, very high, means it is nearby 0.35, but some of the case is very less also. Now our intention is to obtain that a network which is having less stability index as well as less loss also. But this is a very small network, you see, this is a very small network. For this small network only a lot of configurations are there. Out of say for this I think here 2015 minus 1 number of configuration, means a very huge configuration for such 8 bus network itself. But if you do for practical scenario, in practical system you may have 1,000 bus, you may have lakhs number of feeder lines. Now how to configure it, how to check their stability, that is the main concern in our study. We cannot do manually very easily. But if you want to do, you can do it, but it will take a lot of time. And even for a particular man, if you have lakhs number of configuration, entire life he cannot simulate the things. They cannot find the status of the voltage stability as well as loss for the whole configuration. Then we need some kind of artificial intelligence technique which can give you the solution within few minutes or within few seconds. It will give you very easily. So that is why we are going for artificial intelligence technique, graph theory techniques, so which will give you very robust solution as well as very time, means it will give you less time also for getting such solutions, right? So so this is about the line data. And now you see we did for 14 bus network also. So for 14 bus network, this is a distribution, this is a transmission network also. So for that also we have obtained, say, for different configuration different L index value, means a different type of stability index. Here we are calculating the stability using the single line equivalent technique, and this is the overall active power loss and reactive power loss. And you see, for this is some sample of configuration, this is not the all entire configuration. Now if you show you the voltage stability, you can see for uh, for voltage stability, for different voltage stability as well as the active power, you see how what is there. Wherever the active power loss is less, their voltage stability index is less only. That means from this curve we can, from this graph we can say In a power network,
Oh,
if
okay,
the
okay,
active power
done.
loss is less, it indicates that that their voltage stability also better. So in a network, if your active power loss is less, it can, even if you do the simulation for the voltage stability, you can see their stability index also less. That means there is a correlation between
Yes.
this active power loss as well as the voltage stability index for a for any power network. If your active power loss is less, then definitely voltage stability will be more. So on other way, you can say for a power network, if you want to improve the voltage stability, you can reduce the active
What
power
number
loss.
is this session?
So this is one approach
Session 12
for
and
improving the voltage stability index.
10 to 12.
So that is why we are doing sometimes
Something
some
like
load
that, right? So
shedding.
basics
If
of
for a particular
right side and left side.
zone, if you have more number of loads, more then what happen? They are utilizing more power. Then sometimes voltage may fall. Then what we can do, we can shed some of the loads also. Similarly, if we have
And
some
power
control over
substitution.
reactive power also, you see wherever the reactive power loss is more, there only voltage stability index is more. Means sometimes you see it is reaching nearby one also. That means it is unstable. Wherever the reactive power utilization is more, there only voltage stability is more only. And wherever the reactive power utilization is less, there only voltage stability is better, means less only. So here also you can see that if you have more reactive power loss, then how you have to manage the reactive power also to improve the voltage profile as well as the voltage stability index. You can utilize some fact device, you can utilize some capacitor, eh, as well as so these are the options you can do it. So that is why in modern power system we are utilizing some devices, but cost also one important part. But since you see, if you do, you see at the same time, you see we can manage this reactive power as well as the active power loss as well as the voltage stability by means of different configuration. You see here in a 3D we have shown for different for a particular configuration what is the active power loss, what is the reactive power loss, and what is voltage stability index. So if you check about this one, you see here corresponding mean volt. You see this axis will give you the active power loss, this axis will give you the reactive power loss, and this height will give you the stability index. So you see wherever the at active power and reactive power is less, you see wherever the active power and reactive power less, they are only we are they are only we are having less stability. Means they are only less stability index, means the system become more stable. And wherever the for here you see the our active power also active power loss is 80 megawatt, and reactive power is 300 megawatt, our stability is 1. Okay, and for here you see, if we see the 3D, here also you see it is also like that only. Means we are having more active power loss, more reactive power loss, stability index also 4 only. So so is it clear? Till that point is clear. So now I am going rapidly to our topic, that is application of graph theory to control strategy for voltage stability enhancement in radial configuration. Now see, all of you are going for radial configuration, distribution network, mostly radially operated. Why? So so for radial network, this is a simple network, and the which cost for that radial network is less also, and the react and the coordination, relay coordination also very easy for that one, and the short circuit current also less amount. and that is why we are going for radial
Ah,
network. So people are obtaining, people are making more
so rush danger.
means people are choosing radial network because of that reason only,
Principal,
because it is very simple network, operation is very easy, and it's the cost which is involved for
ask
such
repeatedly
things is
principal.
very
He's
less,
telling
and
stricter
and
principal.
and as well as
Confuse
the
opinion
protection
principal.
coordination also very easy. So that is why we are going for radial network. So but the radial mesh network is much more reliable. I already discussed it. So now this is about some basics of the graph theory. So here one network is there, and that network is converted into graph. So see, these are the different nodes, bus or nodes, and that is given by some dot point. Some you see in this graph. Some kind of nodes are there, and we are having that line. This line has given by some edge. So here a three bus network represented by a three node and three edge curve. Right now, if you want to make it radial, we should disconnect any of the line such that it will be not in mesh condition. There will be no loop. So now here we are having some kind of that one means this is a 14 bus network. This is for 14 bus network equivalent. This is one graph, and this is the adjacency matrix. Adjacency matrix means what? We are having the row and column. In the column also we are putting nodes, and in the row also we are putting nodes. Now we have to check the connectivity between
Silent
one
control
and
related.
between I node and J node. If there is any connectivity, then we can put it
This one only.
one. If there is no connectivity, then we can put it zero. So now suppose Aij for for a adjacency matrix, if Aij is the element of the matrix, then Aij indicating the status of the connectivity between I node and J node. If between I node and J node there is a connectivity, then we can put it zero. If there is no connectivity, then it will be if there is a connectivity, then one. If
Some
there is
coding
no
language
connectivity,
like
then
this
there
only.
will have to put it
No,
zero.
but
So in this way we can frame a adjacency matrix which is useful for our graph theory applications. So now if you have a 14 bus network, the size of the matrix will be 14 cross 14.
sir, we will purchase
The
that principal.
Go to just to click on go to meeting, sir.
Now we are utilizing here the QUSCAL maximum spanning tree for our graph theory applications only. So what is QUSCAL maximum spanning tree? It was developed by
Click on buy now.
Joseph Kruskal. So what is Kruskal maximum
Second page, sir. Because
Kuskal's
per year if you are
algorithm?
buying, it will be
Kuskal's
60,000.
algorithm is if we have
So per
some
month, it is 90,000.
graph,
One month
so we have
20 means
to, from the
80,000.
graph we have to pick up the cheapest link. Then first we then after that we have to check uh, the next cheapest thing. Then
Now we are
in
buying
this
this
way
one. Select
we
this.
have to complete, we have to check
This one enter, this one enter.
all these status, right?
That
So now I am just
all these 16
explaining
will be
that one.
total.
Suppose we are having some network. Now here you see the age value
So
is
if you
two
using
seven
predictor
five
method,
eight
what you have to
four
do, this
three
one 20
ten.
MB, you have to click
So
on
out of that, here you see
you have to
out
click
of
on this one
all
for
these
cancel. All of them are
age,
auto-renewed.
our
Ma,
less
Because
value
this
of
is
the age is
auto-renewed
2.
on
So first,
December.
so what we can do
otherwise
first,
I will do the
from this
We
algorithm,
can
they will select
copy them
okay.
also, we can
the first
put it like
two.
that. That's all.
Then after that, which one is the lesser one? It will be
Any
next
other
will
option?
be the 4, or next will be the 3. But it will do
Now it
in
is
such a
ready.
fashion
Now
such
is
that
ready. It is
there will
okay.
be no loop,
Now you
and
have to
there will
create
be
account.
no
User one, it will be
node
different.
should be isolated from the system, right? So now they will select the
First,
next one. Next one, this 3, they will select the
first
3.
folder.
Then after that, which one will be the applicable? After that, 4. So after that, they will select the
Password
4,
algorithms.
the edge where having the weight of 4, right? So next after that, they will select what, 5, I think. Now I'll just check it.
Phone number
They are
message code.
selecting the 5.
Your name
And now
it.
you see, now after that they can select which one they can select. If they can select 6, then what happens? Then it can make a loop. But our main interest to make the radial network. If we have some mesh network,
Next month
from that we
day we
have
should go
to
and
determine a mesh network. So that is why we
go
should
under this one.
avoid the loop. So next we have to
We
go.
cannot do it here actually.
So that is why we are
Once
not, even though
it will
6 and
be after
8
the
is
network
lesser
card.
than
So
10,
you have
we
to
are
call these
selecting
people and
only
you have
10.
to send the
Because
mail
of
without
that reason
data
only,
section. So
if
once
we
that is done,
select
they will.
6, 10 or 8, anything else, that
In Zoom
6
also
and
it's
8,
like the same.
then it will make a
Whether we
loop.
did for
That
science
is
or
why, as per the algorithm, they
we
are
purchased for 1 month,
selecting
exactly 2 to 3 days
the
before
lesser
one day
value,
they
but
called them
at
and
the
sent it
same
as
time it should not
cancel the
Cancel
cancel
make
option.
any loop. So
That
this
is
is
that.
about the
Yes,
Kuskal algorithm.
that will be
They
cancelled.
are
That is a condition option.
selecting one by one less value of the
No,
edge,
we should
and
call them.
finally
See,
they
a
will
contact us
form
option will be there
one
actually in the
network
bottom.
such that there will be no loop. Okay, so we are utilizing this Kuskal network to determine a optimal radial
You
network
can
from
go.
a mesh connected network. So we are having a IEEE 14 bus network which is completely mesh network. During planning purpose, we have to find
Bro,
out a
free
optimal radial
conference call
network
కూడా ఉంది
such
సార్
that
బట్
the overall voltage
కొంచెం
stability
బ్యాక్గ్రౌండ్
and
నాయిస్
loss will
మీ
be less.
బ్యాక్గ్రౌండ్ ఎప్పటికీ
Now
ఆన్ స్పీకర్
another
పెట్టేసారు
concern is there.
By today
కోవిడ్
evening
టైంలో
we should finalize this.
ఫ్రీ కాన్ఫరెన్స్ కాల్ ఇస్
So
దేర్
now after
దానికి
going through,
పార్టిసిపేట్
you
ఇస్తాను
see our
ఇట్స్ ఫ్రీ
overall thing
వన్స్ యూ
is
కెన్ ట్రై
24. Total sum of
బికాస్
the
ఐ కండక్టెడ్
age
ఎవ్రీథింగ్
is
మై సెల్ఫ్ గోవా
24.
శ్రీనివాస్ కండక్టెడ్ కదా they don't know
So
That
now
one of them started
we have to
చేసాం.
utilize our
Once
algorithm.
try that.
What we have to do
like a
from the
free
system
conference
data,
call
we have to do the load
2
flow,
minutes
and from the
One day,
load
one day,
flow we
one day
have to
school.
find out
free conference
the
call
current carrying, we have to find out the power carrying capability limit between any two successive
completely
node
free sir
across the line, and we have to consider
Actually,
it as a
clarity
cost
ఉందనుకుంటా
value.
at the time
Now
because
after
it was
that cost value, we
class
have to
నడుస్తుంది కదా
utilize it in maximum spanning tree algorithm to find the network graph whose cost will be maximum.
article
Okay, so what we are doing basically in this approach, first of all we have to do the load flow solution. From the load flow solution we can get the flow of the power of each of the line, and we can find out, as well as we can find out the nodal voltage as well as the angle also, and from that we can find out the maximum loadability limit for a line. So suppose we are having
no problem.
two
This
nodes,
solution
their
is there.
voltage is V1 delta 1, another node
Let us
having
do
V2
another.
delta 2, and they are having some impedance say Z, or maybe reactance say X. So now how can I find out their maximum power capability limit? By V1 V2 sine of delta 2 minus delta 1 divided
Yeah,
by that X will give you the maximum
direct
loadability limit. So suppose if we have a system, we have to check for a system what maximum power they can carry. So now that part we have given here as a cost
You
value
will come,
of
sir.
the age of the graph. So first of all we have to convert this network into graph, and that network age value has been obtaining by the load flow solution by that loadability limit, and that can be utilized for choosing the optimal radial network, and this can also give you less power loss network, as well as voltage more voltage stable network. So here you see we are having a network of 4 bus network. So you see, so from one bus to another bus we are calculating that feeder line, that load current capability limit by V1 V2 divided by X into sine delta. So this was given as a cost matrix. Since our network is bigger network, that thing we have obtaining from load flow solution itself. So now suppose we are having that network. Now if we want to from this network, if you want to find out the radial network, so we have to open one any of the lines. So we are opening that one. So you see we are having that P1, P2, P3, P4, all these line loadability limit. So we are removing the line which one having which one having that
ఇప్పుడు
so we are having the loadability limit of the line P1, P2, P3. P1 is more than P2. We are assuming here P2 is more than P3. P3 is more than P4. So
ఇప్పుడు
since
థింగ్ ఈజ్
we are opening here the lines which one having less low current carrying capability limit. So the same so this problem can be solved using Kuskal's method, but we have to utilize inverse Kuskal algorithm, because that Kuskal algorithm giving
ఇక్కడ
you the solutions. They are just removing the highest weighted edges, but here we are utilizing the reverse case. Here we are utilizing in the concept where
This
the
first time when
lower
I was conducting this
load current capability line we are removing. So that is why we are
how long
removing
remained
the
in
lower one. That is why we are utilizing that that inverse Kuskal algorithm.
but
So this is our things. So we are having, suppose this age 1 2 3. So since 3 age is more, that is why we are removing the age number. We are removing 3 only, not that one. So out of these things, you see, we are we what thing we have to do? We have to remove the age which one having the less. So for our case 4C will be so we are having different options. So 4A is the actual network. So 4B is one configuration, 4C, 4D. So out of that, I
something different
4 1 as per our algorithm we have to utilize 4C. So this is our flow chart we have utilized here. So now we are utilizing, suppose this is our 40 node network, and here this network has been taken as a test system, and these are the and this is the a cost matrix. So this cost matrix has been obtained
don't know whether they
from
will consider or not.
this cost matrix has been obtained from load flow solution. This is nothing but power carrying capability limit. So from load flow solution only we have obtained that one, and we have utilized it for
But consider
Kuskal algorithm as a cost matrix, and finally it will give you some graph. So it will give the result something like that. You see there is no loop. It is we have utilized the MATLAB biograph toolbox for finding that things, finding this maximum
సార్ అడిగిరా ఏం కాదు
spanning tree,
సార్ అడిగి
maximum spanning tree graph. So this can be this gave that result. And finally you see so these are the different configuration we have done by manually. So if we have manual configuration, so these are the different configuration, you see. For we can do the configuration with the help of manually only, means we are opening S19, S30, S11. In this way we may have a number, we may have 23 number of configuration. So these are all are giving voltage profile, power loss, different thing. So out of that, you see, whenever we are applying the Kuskal's maximum spanning tree, that time that result is giving the lesser one. Here 24 number is configuration which is obtaining from Kuskal algorithm, which gave you the power loss 4.301 megawatt, and active reactive power loss 3.860 megawatt, as well as the voltage stability also 0.2245. So you see this result obtaining using that Puskal's maximum spanning tree. Wherever whenever we are utilizing the manual operation, we can obtain many configuration, but I
Still we'll have
but
some other
if you are really
application
a
like
lucky
Assign.
person, you can get that
Assign
configuration
based on
immediately. But if you are
like
not
our
having such luck, you
Zoom.
cannot obtain
Previous phone
that optimal
that
one.
day we can use
So
it.
for that, to get such
Previous
a
can perform
network,
for another.
optimal network, you need
Any US
lot of
screens or
time,
any other
and you have to consume lot of time also.
not like that sir.
If you utilize the manual
This
configuration
that won't
one by one,
this will
opening the
share to
switching
tech
also,
engine
oh,
directly
it will
Indian
take
ID.
long time.
But
And
US screen can
in number of load flow also you need to do.
sir
But if you are
no problem
utilizing the
no
QISCET algorithm, within few seconds, 2 to 3 seconds, you can solve the problem. This is for 14 bus network. Even you can do for 1000 bus network also, you can do the solution easily. But for that, you have to find out the cost
So put the
matrix.
HOD and send it to
Cost,
me.
you have to determine the cost matrix, and from that only you can easily get the practical solutions.
That way even
So
reading also.
so this is about
Actually,
different configuration. So
custom
final,
one.
after doing in these solutions,
Exactly custom.
we have obtained that if you,
Custom 1000
that if you opening
Oh,
some feeder line here, dotted line means the lines,
2003
the feeder lines which is open.
2003
So
months.
these
Sir,
things has been, this
why you
information has been
profile
obtained
waiting 3 months
from our
ago?
solutions.
Then I can say
So
you can
from these
use for
solutions
any other
only, I
entities
have just
also.
removing that line
You
which is
conduct
given by dotted line.
we will conduct
So
for
that
every
that
customers.
means we
You
have
only
to
have to conduct
open the exchanging switches for
because
that particular
1200
feeder,
register only
which
one
is
month
given by dotted
no,
line here only.
1200 is
So this is
continuously for three
now
months you
you
can
see
use for
here,
India also sir.
this line become a
Because
radial one, and there is no
every
load
customer
has been
configuration
isolated
different.
from the system. So this is the optimal radial
Sir,
network
EEE people
which
change
gives
all
you
these
the
options.
optimal solutions.
Sir,
That means
systems will complete.
you are having stability, more stability, and active power and reactive power loss is less
పెట్టే
compared to other
no
configurations.
problem sir.
So with
Again, we
this, I'm
have
stopping here.
1000
Now, if you
participants
have any question,
they have
please
zero
ask me.
visibility.
I'm happy to give your
Zoom
answer.
only, like Google Meet or no problem. Yes, sir. I conducted that, sir. Completely. Even mobile app also we can install. Use it.
So these are my references.
Then the thing is, after registering, we have to create the ID and then we have to send it in the group to all the participants. They have to install the free conferences. They will do that. Again, only next 6 months again check up, sir. After 6 months. ఏమంటున్నారు అదే ఇప్పుడు వెయిట్ లాస్ అవుతుంది సార్ ఇప్పుడు ప్యాంక్రియాస్ ప్రాబ్లమ్కి ఫస్ట్ టైం బిఫోర్ 6 months I was checking it was
So thank you for your patience of hearing. So now I'm waiting for your questions.
Participants, you can ask any questions.
Created or not? Yes, created, no problem. Let me download and put it immediately. Suresh. Certificates కూడా రెడీ సార్ no problem.
Any questions?
Session is over.
I think no one is asking any questions, sir.
Nobody last. Sir,
In
thank
future,
you
if
very
you
much, sir, for giving your valuable presentation.
okay.
So, participants, you have any queries? You can just type here and even feedback link for this session is already posted. Any queries, sir?
Yes, sir. So, Deepu Sarkar, sir, thank you very much, sir.
Thank thank you for inviting me. I
Sure,
hope
sir.
that if you want to, anybody, if you want to do the research, particularly on network reconfiguration, if you need any kind of support from my side, I am always here. Okay, so anytime you may contact,
Sure, sir,
I can help
definitely.
you. Thank you, sir.
Thank you, sir.
Thank you. Thanks a lot.
Thanks a lot, sir. Sir, tomorrow session,
పొద్దున్న పంపించింది పెట్టారా ఫీడ్బ్యాక్ పొద్దున్న లింక్ పంపించాక అదే
అదే
పెట్టారుగా
పెట్టండి, అదే పెట్టండి.
ఓకే
So tomorrow I'll start the same time 9:30.
Yes, sir.
Okay. So
We'll meet here.
tomorrow we'll do that. We'll start the topic. I think 9:45 will be fine, sir. 9:45
Sure.
or
9:45
10
is okay,
o'clock.
sir. No problem.
9:45.
Yes.
Okay, so 9:45, and tomorrow I'll discuss about the network reconfiguration by some different technique using some optimization as well as the machine learning and technique, machine learning
Sure.
technique.
Sure, sir.
So the same solutions can be obtained with the help of AI also. We'll discuss that one, and we can also get some, I think, juice from that for your further research. So in how the different way can be solve that configuration technique. And if you need any paper, I'll share also my publication. I have almost 8 to 10 papers on network reconfiguration for different techniques. Right, for graph theory I'm having one in Elsevier, another in I think two in Taylor Francis, another in Elsevier. Okay, so I'm just sharing that paper also. You can get a lot of information from there also, and after tomorrow's presentation also I'll share my 4 5 papers. Okay,
Okay, sir.
thank
Okay,
you.
sir. Definitely. Thank you.
So sir, I'm leaving here.
Sure. Okay, sir. Thank you.
సార్ ఎవరు వచ్చిందా స్క్రీనింగ్
So, thank you, participants. And we'll join for the tomorrow session. 9:45 sharp, sir. Thank you, sir.
So this madam attended today. Today you sent some link now, some name yesterday.
She
She
registered.
attended.
Actually, they were about to register. Actually, they were not able to go into the link. So they can complete the payment. Tell Ra. Not still. Another 5 minutes.
ఇదేంది ఇక్కడికి వెళ్ళాలి?
That password is about to reset.
Already it was over, sir. Madam. Suresh. J106. Yeah, computer lab. Comes under department only. But we need one venue in charge, madam. For that we requested. Thank you, madam. Bye. Venue in charge of వస్తున్నారు. At least they will sit continuously there. ఏందో organization.
You can
What's
turn off.
అసలు స్క్రీన్ షాట్లు కూడా తీసుకోలేదు అన్ఫార్చునేట్.